degree and leading coefficient of a polynomial. The definition for a polynomial is you cannot divide by a variable or have a square root of a variable. If you divide by a variable or have a square root of a variable, then it is not a polynomial. Degree is the highest exponent if you have a single variable, or exponent total of a term if you have multiple variables, which is the sum of the exponents. And the leading coefficient is the coefficient or number in front of the degree. Title of the first section is Find the Degree and Leading Coefficient. In this section, we'll find the degree of a polynomial and also the leading coefficient of a polynomial. First question, negative 3x squared plus 5x minus 7. Find the degree. When you have a single variable, the degree will be the highest exponent. Looking at the exponents, the highest exponent is 2, so the degree would be 2. For the leading coefficient, leading coefficient is the number in front, or coefficient for the degree. Since our degree is 2, the coefficient of that term is negative 3, so the leading coefficient would be negative 3. Next problem is 5a plus 2 plus a squared. The degree, which again is the highest exponent, would be 2. And the leading coefficient the coefficient in front of the highest exponent, which in this case would be 1. Next problem, square root of y plus y cubed. In this problem, the highest exponent would be 3, but looking at the other term, we have square root of y, or square root of a variable. And looking back at the definitions, if you have a square root of a variable, this would not be a polynomial. If you have a square root of a variable, or again, if you divide by a variable, it's not a polynomial, so there's no degree and no leading coefficient. And last question for the section, 2x squared y plus square root of 2 x squared y cubed minus 4 x to the fourth. In this problem, we have a square root of a number, square root 2, which is fine, so this is still a polynomial. The degree, again, is the highest exponent, or when you have multiple terms or multiple variables, it's the sum of the exponent term. This first term would have a exponent of 1 for the y, so the total would be 3. The second term, the sum or total would be 5. And the last term, the total would be 4. So our degree, the middle term, adding the x and y exponents, the degree would be 5. And the leading coefficient, again, the number in front of the term with the degree. X squared y cubed was the degree 5. The coefficient, or number in front, is square root of 2. Types of graphs. Types of graphs are based on the degree and the leading coefficient. There's 4 types of graphs separated by the degree that they have, either odd or even, and the leading coefficient, either positive or negative. Looking at the first 2 graphs, if they are even means it has an even degree, like 2, 4, 6, or 8. If it's an even degree, both sides either point up or both sides point down. If it's a positive leading coefficient, a positive number, both sides will point up. If it's a negative leading coefficient or negative number, both sides will point down. And likewise for a odd function. Odd, again, means a odd degree, like 3, 5, 7, or 9. If it's a odd function, it either starts at the bottom left and goes to the top right, or it starts at the top left and goes to the bottom right. If it's a positive coefficient, again a positive number in front of the degree, it'll start at the bottom left and go to the top right. If it's a negative coefficient, it'll start at the top left and go down to the bottom right. All the curves in the middle of the graph are based upon the rest of the function. Title of the first section today is Graphing. Determine zeros. And max/min. In this section we'll graph polynomials, we'll determine the zeros, and we'll find either the max and or the mins. First function we'll look at, f of x equals x cubed minus 2x plus 6. Looking at this function, we can decide the shape of the graph based on the previous section. This is an odd graph. X cubed would be an odd graph, and the coefficient in front is positive, so we'll have odd and positive. So looking back at the tables we just did, this graph will start at the bottom left and curve up to the top right. To get the precise graph, we can make a t-table, x and y. We can use any numbers for x and y, but the numbers we'll use for this section will start at -2 and go up to +2 using 5 values. So we'll have -2, -1, 0, 1, and 2. Plugging these numbers in to the expression, we'll find f of x, or the y value, and then we can graph the 5 points on the next y-axis. Starting with -2, if you plug a -2 into the expression, -2 cubed would be -8. -2 times -2 would be +4, and adding 6 to that, we'll have -8 plus 4, which is a -4, plus 6 would be a +2. So our first value would be 2. Repeating for the next 4 values, -1 cubed would be -1. -1 times -2 would be +2, and plus 6. -1 plus 2 would be 1, plus 6 would be 7. Plugging a 0 in, the x's will be zeros, we'll add 6 to that, so 0 will be 6. Plugging a 1 in, 1 cubed would be 1, -2 times 1 would be -2, and plus 6. 1 minus 2 would be -1, plus 6 would be 5. And last number we'll plug in 2. 2 cubed would be 8, minus 2 times 2 would be 4, plus 6. 8 minus 4 would be 4, plus 6 would be 10. Taking these 5 values now, we can graph them on a xy axis to get the graph for the function. The first point that we have is -2 and +2. Second point is -1 and 7. And 0, 6, 1, 5, and 210. Graphing the 5 points, we'll connect them in order from left to right that we graphed. And we'll get a shape that looks similar to the graph that we originally thought it would be, which is starting at the bottom left and going to the top right. To finish this graph, we want to find these zeros. The top right of the graph goes off to infinity, so there'll be no zeros on the right hand side, but the left side of the graph will continue to drop down, so we'll have some zero on the negative x-axis. To find that zero, we can plug another number in by continuing the t-table. Since we left off at -2, we can plug in -3 to see if that's where the zero would be. If you plug a -3 in to the original equation, -3 cubed would be -27. -2 times -3 would be +6 and +6. -27 plus 6 would be -21, and -21 plus 6 would be -15. So -3, if we drop the graph down 15 spots, we'll have another point that we can graph and connect that to our line. Since we know this is an odd positive graph again, the graph will continue to drop to the left-hand side. To find the zeros for this graph, looking at the x-axis, the zero will cross between -2 and -3. So our zeros, since we don't have an exact value, we can put between -3 and -2. And the last part for this section, max or min. Max or min will be relative max or relative min. What that means is we'll ignore all the negative values that go down to -infinity, and we'll also ignore all the positive values that go up to +infinity, and just look at the middle of the graph with the curves. The relative max will be the top of the curve, and the relative min will be the bottom of the curve. So for the max for this graph, we'll have x equals, and the top of the curve in the middle of the graph occurred at -1, so x equals -1. For the relative min, again ignoring the negative values, but back at the middle of the graph, the bottom of the curve was at +1, so the relative min is at x equals +1. So we'll have our graph. We have 1 0, which is somewhere between -3 and -2, and we have one relative max and one relative min.